We're now going to look at volume stoichiometry problems. And these are very nearly as easy as the ones we just looked at. They will also be just one step, the mole ratio, because we have started in liters and we're going to finish in liters. And as I'll go through one of them in a moment, you'll see that there's really not that much to do. It's a little bit more difficult than the mole ones just because you have to recognize that I can do volume the same way. Now, there are, of course, 3 steps to stoichiometry problems. I'm going to put it over here. The first step is go to moles. The second step is our mole ratio. And then our third step, go to desired units. That would be our 3 steps. So if we did step 1 here, well, in fact, even before I start step 1, again, I'm going to do just like I did on the previous problems. Put down my question mark. Well, let's see. What volume of hydrogen? Okay, there's my question mark. To react with 5 liters of nitrogen. So here's the 5 liters. Now, it just tells me, by the way, when we get to it, what will be our mole ratio? 3/1. So when we get to step 2, that'll be our 3/1. So now let's do our step 1. Go to moles. Okay, well, to go to moles, just like doing mole problems that we had last week, I would take, okay, that's what they told me, the 5 liters times 1 mole for every 22.4 liters. Basically, this comes out 0.223 moles. And just sometimes this is also helpful when you're doing all 3 steps. 0.223 moles of N2. So it's the N2 that I change from the 5 liters to the moles. Now, step 2, mole ratio. Going to take my 0.223 moles. Again, it's mole ratio because it's a ratio between moles, times the, as we've already said, it's going to be 3/1, which is 0.669, and actually if I had another digit it would be 0.6696. But we're going to just leave it like that. Now, what is this of? Well, this is of the question mark part, so this is of the H2. So 0.223 moles of N2 needed 0.669 moles of H2. It needed 3 times as much because here's a 3 compared to that 1. And then we want our liters, that's our desired units for our answer. So 0.669 moles times 22.4 liters per 1 mole. And we get 15 liters. So there would have been all 3 steps of doing a stoichiometry problem. However, as I said at the beginning of this paper, really we only need to do 1 step because step 1 was divide by 22.4. Step 3 was multiply by 22.4. If I had simply said take my 5 liters times my mole ratio, there's my answer. Now you can do all 3 steps and get there, but the reality is you need to make sure and be back in liters. Have any peekers? So again, while we can do all three steps, why do all that work? Worry about rounding issues or anything like that. We just do our one step, the mole ratio. Problem 2 here. What volume of ammonia is produced in the reaction in the problem above? Okay, now, I'm just going to rewrite the equation for a moment. Question 2 says, what volume of ammonia? So the question mark spot has changed. Now, we still have problem 1, so that still means 5 liters of the nitrogen. But now that I have a new spot for my question mark, my mole ratio has changed. And it's now 2/1. So again, back to an earlier question, how do I know what goes on top? That's where it's so important to, where does the question mark go? What's the question? What's the problem asking? That tells you where the question mark is. Okay, problem 3. "20 liters of oxygen. How many liters of carbon dioxide?" So by looking at the question, here's the question mark. How much carbon dioxide? Here is what they already told me, the 20 liters. Take that 20 liters times, what's on top? What's going to be on top? The 3. What's on the bottom? 5. Again, we can cancel. There's our answer. 12 liters. Number 4. Now this says milliliters. Okay, no problem. If we're going to be in milliliters and we want our answer in milliliters, I can just go ahead and treat it just as if I was in liters. So let's see, 30 milliliters of hydrogen. How many milliliters of oxygen are also produced? There's my question mark. Again, if there's nothing in front of the item, the substance, it's got a 1. So my mole ratio there will be 1/2. 30 milliliters times 1/2. 15 milliliters. Question 5. How many liters of carbon dioxide are produced if 7.5 liters of propane are burned? Question mark has the 3 in front, 7.5 liters. Propane is a 1 in front. My mole ratio will be, what will it be? 3:1. So 7.5 times 3:1. 22.5 liters. Proceed. So almost as easy as the mole problems. Really, the extra part is just remembering I can do liter to liter or volume to volume the exact same way I can do mole. So, any question on this one? Yes?
On the last one, when it says how many liters of oxygen are necessary in the last question, is that the same answer?
Oh, good point. There's actually a second question here. So a second question means now I have moved my question mark So if you wanted to rewrite it again, I didn't even notice that at first, C3H8. I'm just rewriting it to point out what's going on. 3O2 plus 4H2O. So now it says how many liters of oxygen are necessary. Well, I still have the 7.5 liters here, but now my question mark's over there. So it's a whole new problem. This one would be the 7.5 times, now it's 5/1. So 37.5 liters. So good question. Now, I might also point out, when you have a situation like that where you have two questions in the same one, it's always a good idea to label it. So the 22.5 liters here, well, that went with the CO2, and the 37.5 went with the O2. And don't leave them blank. In other words, just two answers there. Even if I have the liters, I still don't know for sure which one you're saying goes with which. So good question. Anything else?